Hey guys, today we're going to talk about Newton's second law. Newton's second law states that if a net force is not balanced, an object will accelerate. And it's shown using the following equation. F equals m times a. And F is the force in newtons, m is the mass in kilograms, and a is the acceleration in meters per second squared. So it's a simple multiplication problem. We will have to divide if we're solving for something other than force, but it's pretty straightforward. So practice with Newton's second law. What is the force applied if a 0.75 kilogram basketball accelerates at a rate of 1.2 meters per second squared? So over on the side, we're going to list our knowns and unknowns. F equals, M equals, A equals. And the mass is 0.75 kilograms. The acceleration is 1.2 meters per second squared, and force is our question mark. So using our equation F equals ma, we plug in our known variables, 0.75 times 1.2, and the force required to move this is 0.9 newtons. So 0.9 newtons being added to this basketball allows it to accelerate at a rate of 1.2 meters per second squared. So is it ever that easy? Sometimes yes. In the very beginning, I'm going to have you just do straight F equals ma equations, where you're going to have to solve for an unknown variable. But more often than not, I'm going to take it a step further, and we're going to have to use multiple forces acting on an object. We can use this equation paired with our free body diagrams to help us solve for unknown variables, but we have to create a net force equation to do this. So essentially what's going to happen, instead of just F equals ma, you're going to have F net equals ma, and then you're going to have to solve for what F net is if there are multiple forces acting on an object. So we're going to take a look at that next. A cart is accelerating to the right down a track. There are 2 newtons of friction acting on the cart. The applied force pulling the cart is 5 newtons. So what is the net force acting on the cart? First thing we're going to do is draw a free body diagram. So there's our cart. We have been told that we have an applied force going to the right with a value of 5 newtons, and we have a frictional force going to the left because that is always opposing motion, that is 2 newtons. But this cart has 2 other forces acting on it. It will always have gravity going down, and it will always have a normal force going up, and those 2 values are equal because that cart is not moving vertically. So now we have to create a net force equation. The first thing we have to decide, which direction do we care about? The lefts and the rights, or the ups and the downs? We care about the lefts and the rights because those are the arrows that are not equal. So I'm going to write F net equals F applied minus FF. And I put F applied first because in a number line, this side's always positive and this side's always positive. So I tend to put those first because I want the positive values coming first. So if we do have to subtract, I know if something is speeding up or slowing down based on the sign. So this is our basic F net equation. But for step 3, we insert the known information and solve for the unknown variable. So this problem's pretty easy because it's only asking us to solve for net force. So F net is our unknown, F applied is 5, and FF is 2. So F net is 3 newtons. So that's a simple, harder problem. We're using multiple forces, but we just had to solve for F net. So now we're going to take that same example and take it a step further. A 0.75 kilogram cart is accelerating to the right down a track. There are 2 newtons of friction acting on the cart. The applied force pulling the cart is 5 newtons. What is the acceleration? So now I'm not asking you to solve for the F net. I'm asking you to break that F net down and solve for the acceleration. So again, we're going to draw our free body diagram. It's going to look exactly the same as the last slide. So FAPP going to the right, FF going to the left but littler, FG going down, and Fn going up, and those are the same length. We have to create a net force equation. So F net is FAPP because that is the positive direction, minus FF. And those are subtracted because they're pointing in opposite directions. Now I'm going to take this equation and substitute one more thing. I'm going to change this F net to an M times A because Any F net that is not equal to 0 causes acceleration. So this substitution is going to allow me to break down the mass and the acceleration to solve for one of those variables. So I'm going to take that same equation and rewrite it down here. I'm going to list my knowns and unknowns. Mass is 0.75, A is my question mark, F applied is 5, and FF is 2. So I have 0.75 times A equals 5 minus 2. 0.75 times A equals 3, and then I'm going to divide out these two numbers, and A equals 4 meters per second squared. So even with 2 newtons of friction acting on this cart, it is still going to accelerate 4 meters per second squared. So this is what we're going to work on in class. We're going to be calculating F nets, masses, accelerations, or any unknown variable given certain situations. So I'll see you tomorrow so we can look at this and practice it a little bit more.